Let's get started. This is the first meetup that will be in English, as we have English-speaking Miško, our special guest today here, and he speaks a little bit Slovak as well still. But most importantly, I believe we have a couple of guests today who are English speakers, so let's make it first time international. First of all, welcome to Shipmonk R&D headquarters in Prague. And it's really great that you took your time today during the summer and join us for today's session. Today's session is very special to me because I have the privilege to invite my very close friend Miško Hevery. Miško Hevery is one of the most technical person I know. However, I never did anything technical with him. The only thing I ever did, I cooked for him and catered him and his family, and we are great family friends. So when I learned that he is coming to Prague, I was super excited not only to invite him here, but also learn what he is up to. So without further ado, Miško, the stage is yours and welcome.
Thank you. Thank you for all the steaks you have cooked. I guess this is a payback for the steaks. How you doing? So I'm Miško. I'm originally from Slovakia. I've lived in the US for most of my life. I speak Slovak, a little bit of Czech because my wife is Czech. She's right here. Hi. But you know, I speak more like a 13-year-old because that's when I left to the US. So my Slovak or Czech is not so good. Anyways, today I want to talk to you about page speed insights. So page speed insight is the thing that Google does to measure your website. Are people familiar with that? Yeah, okay. And basically what they're saying is like, look, if you have a website that is super slow, we're going to penalize you as a way of motivating you to get faster, because we think that having a fast website is actually important for the customers, and it's important for the users, and it directly translates into whether people will buy things or not on the websites. And so Google started this thing, page speed insights, and the idea is that by pushing the information out to the outside world, that the outside world will eventually start behaving in the way that's congruent with this particular thing. So I want to talk to you about specifically, whoa, how do I mute this here? I want to talk to you specifically about what we are doing to make page speed insights super fast. Turns out this is super hard. So first, a little bit of introduction. I'm a CTO at Builderio. Builderio is a company that does content management system. I'll talk to you about it a little bit more later. The thing I'm known for is Angular, AngularJS, and Karma. And then previously, I did a lot of clean code talks on YouTube, convincing people that testing was a good idea. That was like 10 plus years ago. I'm sure you guys heard of Angular, right? Okay, so that's my fault. Sorry about that. Okay, so let's talk about Builder. Builder is a company that does headless visual CMS. So CMS means content management system. Basically, it allows non-technical people to go and edit their e-commerce websites. So, you know, think about marketing people that constantly want to say, oh, it's 10% sale. Next week, it's 15% sale. Then it goes back to whatever. And the last thing the engineers want to do is constantly just update the website with like silly comments like that, right? So the idea is here that the constant updates that the marketing wants to do is the content management part, and some other system can take care of it. And instead, engineers can focus on like, what is the shopping cart experience look like? You know, how do you buy things? How do you put things in the shopping cart? What are the components that the website is built out of, etc. So what's unique about Builder is that we have something called a sorry, the headless part means that it is not hosted by us or like a WordPress. Instead, it's hosted by our customers. So think like a Gap, right? Gap or Nike or, you know, any other of those large companies that have large e-commerce websites. They can host their particular thing, but they can use our technologies so that their marketing people can update the UI. And when the marketing people don't have to talk to the engineering people, you know, everybody's happy, right? The headless bit means that it's owned by the customers, and the visual bit means that it's actually a drag and drop editor. This is something unique to Builder.io. Most content management systems only allow you to change things like a URL, like I want to show this image versus that image, or I want to show this text versus that text. With Builderio, you can actually decide like, oh, I actually want to move this text above this other thing or rearrange things around, etc. Anyway, so that's what Builderio does. And what we mainly focus on is e-commerce. For it, it's just the beginning. We think we can actually build a drag and drop editor for any kind of UI, and we have technology that allows you to write. One of the things that we have to do when we're headless is that when you write components, we don't know what our customers use, whether they use React, Angular, Svelte, or any other technology. And so we have to make sure that we can integrate with all of these existing technologies. And so we think we can write code once and generate it canonical for all these other systems. We have something called JSX Lite that does that. Anyways, this is just kind of the beginning, and we think we can do a lot more in this area, but it's not what we're going to talk about today. So what we're going to talk about today is actually making the websites faster. So our customers, again, think like Gap, Everlane, or Nike. They have websites that people come to. So like you have a person on Twitter that says like, oh, I just bought this awesome shoes, and the person is an influencer, and so everybody clicks on it. They click on the URL, and it takes forever to load the page. And because it takes forever to load the page, they say like, you know what, this is not important. We're not interested, and they leave, right? And you don't get a good conversion rate. And so to get a good conversion rate, you need to be super fast on time to interactive. And it turns out that the existing set of technologies make this really, really hard. And we all think that speed is money. This has been proven over and over again, that if you can get the website super fast, it will translate into more revenue for the company. And so getting this thing super fast is something that a lot of companies spend a lot of time and a lot of effort to get it done. But it turns out if you look at the industry, if you look at Gap, Wayfair, Target, I'm not cherry picking these. These are just normal things. If you run them through page speed, you're gonna get pretty bad scores. It's kind of typical to get scores in like 20s and 30s. And if you have a company that spends tremendous amount of time, like Amazon, you can maybe get like 60s, 70s, but almost everybody is having a hard time with this particular problem. Like it's super hard to do. And so the point I'm trying to make is this isn't a problem with individual companies. This is a systemic problem to our industry. And I'm going to say that the reason why this is a systemic problem to the industry is because our technologies, the way we build websites, is not actually conducive to make it fast. So one of the things we're focusing on is this new technology called Qwik. And Qwik is an open source framework. And the goal of Qwik is to make sure that your website can get 100 out of 100 on Google PageSpeed. And we have some prototypes up and running. We're kind of investing into it. I'm going to basically talk to you today about all of the tricks. Basically, I want to tell you what issues the existing systems are facing, and then how Qwik takes a different approach to these particular problems, and how we can make like 100 out of 100 in each website. And the premise that I want to say is that the existing generation of frameworks really focus on runtime performance. Everybody's bragging about like how fast they can update page, how fast they can show the UI, but everybody's ignoring the real problem, which is that how long does it take for the application to boot up, right? Whether you choose Angular, React, Svelte, or any other technology, your website is plenty fast. That is not really the problem. The problem is how long does it take for the website to come on up, right? And that's really the problem that all of these technologies are not focusing on. And all of the benchmarks, when you look at them, all of these benchmarks are like, how fast can I update a list? How long will it take me to have a scrolling stock ticker or some kind of performance metric that really talks about a steady state rather than talking about how long does it take to boot up the application to begin with. And the problem is that the booting up part is the thing that's going to affect your time to interactive, and it's the thing that's going to really affect whether or not you're going to have good conversion ratios for your websites. So let's talk about the problem. Above is the top portion is basically the current technology. And I'm going to actually show you this particular problem from the back, right? So almost all the technologies have some kind of server-side rendering technology, right? And like it's a must. Like for all e-commerce websites, you need to have some kind of server-side technology. So you server-side this thing on a server, you ship it to the client, and on a client you have to do a bootstrapping. And let's go back to the end. The thing you want is you want your website to be interactive, right? So you want to end up in this box right here, right here. You want to end up right here. You want to be done. And what interactive really means is that the framework was able to register listeners to the UI, right? It really comes down to that. And so we just want to basically get to the point where everything is registered so that you can go and do interactive parts to it. But in order for the framework to register listeners with the UI, in order for the framework to be able to register the listeners for the UI, it turns out that the framework doesn't know where the listeners have to be. In order for the framework to know this, the framework has to execute the template. And to execute the template, you have to download it, right? You can't just do it. And so in order for the framework to figure out where the Qwik listener is, you have to get the template. So that's code you have to download. And then you have to execute the template. But that's not enough because template really it takes in data. And so you need to get data for your application and then merge it with the template to run the rendering process. And that will actually set up the listeners for you. And so as you go back through it, you're going to realize that in order to do all of these things, you essentially have to download the whole application, right? You have to download all the code, you have to execute all the templates, and you have to run through what's known as a rehydration process, right? Whether you're a React application or whether you're a Angular application or Svelte, you're going to have to do something like this. And this thing, the amount of work you have to do over there is proportional to the size of the application. As the application becomes more complicated, as you add more menus, as you add more hover things and et cetera, as the application becomes richer, the number of things you need to download just keeps increasing. So it's proportional to the complexity of the application. And so while it is possible for you to go and find plenty of examples out there that's saying, look, you can use Preact and you can get 100 out of 100 on a page speed score on a little demo app. As the application grows, and as the application really gets robust and production ready, nobody gets those numbers. Like it's a unicorn in our industry to have 100 and 100 out of these existing technologies. And I mean, I've been chatting with a lot of folks about this. Like I just chatted with somebody from Airbnb, and they were talking about all the effort that they did with React to get some reasonable startup times for their application. And it's a lot of work to get there. So that's basically the existing state of the world. And it is the same regardless of what technology you choose. It doesn't matter what you choose, Angular, React, Svelte, or whatever. This is always the problem you're going to be facing because that's how existing frameworks work. And so instead, let's focus on how Qwik looks at it differently. So one of the things that Qwik does different is, or let me back up a second. The thing on the top, what I call these kinds of framework is I call them replayable. In other words, the framework has to replay everything that the server just did so that it can continue. And this replaying property is endemic to all the frameworks. It's not specific to any one framework. It's all of the existing frameworks have this property. And as long as the frameworks are replayable, you will have slow time to interactive. There's nothing you can do about it. There isn't like best practices or anything you can do. You'll always be in this particular state. So let's go to the bottom one. Let's talk about a Qwik. So Qwik, again, we'll start with server-side rendering. And there is kind of a bootstrap thing. But what's different here is that this bootstrap is super, super tiny. It is less than a kilobyte, and it takes about 1 millisecond to execute. It's essentially nothing. It is so tiny that we actually inline it into your index.html because it's cheaper to inline 1 kilobyte than it actually is to make a separate request to kind of fetch this thing. So that actually gets inline into index.html. And the thing about it is that it bypasses update, render, and everything. It goes directly into interactive. And the reason it can do that is because the Qwik framework serializes all of the listeners into the DOM, right? If you look at the DOM of existing framework like React, you can't tell what the listeners are. There's, the code that comes from SSR, from the server, doesn't give you the information. Like there's no way for you to know. The only way for you to know is to download the code, execute it. With Qwik, you take all of the information you need and you put it in HTML. And as a result, you know ahead of time where the listeners are. There's nothing for you to do. Actually, what the bootloader is just a global listener. All we do is we set up a global listener for your application, and we say, if the user clicks, the event bubbles up, the top level listener grabs the event, looks at the DOM, because you can look at the path as the event has bubbled up, and looks for a property that basically says on:click. And that property will contain a URL, which is the piece of code you need to download in order to process this particular click, right? And so by doing that, your time to interactive is just amazing, because there is nothing to do. You just download SSR, it renders. We all know that HTML is the fastest way to render a page, right? There's nothing faster. Nobody's debating this. And so you just put HTML in there. You have this Bootstrap piece of code, and you go directly into interactive. Now, there is a lot more magic to it than that, but that's basically the basic idea, right? Now, when I say magic, there is things we have to do, for example, to do prefetching. One of the things we don't want to do is we want to make sure that when you first interact with something, when you first click on something, we don't want to be forced to download the whole application, right? Because if we are forced to do that, then you're just moving the problem from here to there. And we don't want to move the problem. We actually want to fix the problem. And so one big difference that we do here is that if you notice at the top right here, this is a big fat arrow. And what it's supposed to represent is that essentially your whole application has to get downloaded at the very, very beginning. There is no real good way to lazy load parts of the application. I'm like, yeah, all frameworks have ways of lazy loading different pages and whatever, but you have to lazy load all of the templates on a given page. There is no way to partially render a page. The thing that's different in Qwik is you can see that there's lots of small places where code could be downloaded. And the Qwik, what it does differently is not only that it has the serialized listeners, but it allows you to sip on the code on as needed basis. So one of the things that Qwik knows how to do is do out of order partial rehydration. What that means is that instead of rehydrating the whole application at once, which requires that you have all the templates at once, Qwik knows how to rehydrate only the particular component that you're interacting with. So if you're not interacting with a particular part of the page, why are you downloading the template, right? There's nothing to do. Like, why are we wasting the time downloading the template and executing it and all the parts that have to happen with it? So because we can focus on individual components, what you end up with is these small places where we download a little bit of code at a time. And as you interact with the page more and more and more code gets downloaded. So that's the basic idea. I can pause here and open it up for questions, or I can continue. Do people have questions? Crickets. Okay. So let me talk to you a little bit about the philosophy here, and then I'm going to give you a little bit of a demo. So the basic philosophy of Qwik is that nothing is faster than doing nothing, right? I think part of the problem with existing frameworks is they try to front load most of the work ahead of time, right? The whole Bootstrap process requires you that you execute stuff, you build things, you just do a whole bunch of work for things that you essentially already have because the server side has it. Oh, one of the things I forgot to mention here is that the top level I said was replayable, right? The client, in order to Bootstrap, has to replay everything you've done. The Qwik has a property which I call resumable. It can continue where the server left off. And I think that's an important property, that the client can just resume execution where the server left off instead of replaying all of the work. And one of the interesting things about it is that, especially for e-commerce websites, right? If you look at an e-commerce website, you'll have things like menus and a shopping cart, but the huge portion of the website is actually static. You can't change, what the shoe looks like, or the t-shirt or something on the site. You can't change the text or description or anything. So there's huge portions that are static, but there are places that are interactive. The menu, the shopping cart, looking at the details, changing the image you have in front, looking at the detail, looking at reviews, right? There's lots of interactivity on a page. One of the things that Qwik allows you to do is to just say, like, basically treat each of these components independently. And the components that are not really interactive, really, you will never download the code for them. You could, I mean, in theory, if you had a button over there, but in practice, because they don't, none of the code gets downloaded. And this is how Qwik is able to cut down on the amount of code that actually gets downloaded to the client, amount of code that gets executed on the client. And as a result, the time to interactive becomes so much faster. Now, the other interesting thing about Qwik is that all of its state is actually kept in DOM. So again, if you go back to the way existing frameworks work, what existing frameworks have is some kind of a bootstrap, right? Some way where you say, okay, now go and run. And what the framework does is it calls the templates, and on calling the templates, it collects information about your application. It collects information about where the listeners are, who's talking to who, what the properties are, and so on and so forth. And the framework has to keep all of this information in JavaScript heap. And this is why the frameworks are replayable, because when you run this on a server and you generate HTML and ship the HTML to the client, the framework wakes up on the client and it has amnesia, right? It doesn't remember anything. It doesn't know anything about your application. And so the only thing that the framework can do is to replay the whole bootstrap process and re-download everything and re-execute and rebuild all of the internal state. Qwik keeps all of the internal state in the DOM in the form of attributes. And because it's in the form of attributes, at any point, you can just take your DOM, serialize it into HTML, ship it somewhere else, and it will continue executing where you left off, right? And that's kind of a very important property. That's the property you want, because that's the only way you're gonna get amazing time to interactive, right? The time to interactive for Qwik is essentially 0, right? It's that 1 kilobyte. It is the only thing you need to do is set up a global listener. Nothing else needs to happen, because the framework knows how to continue where the DOM left off. Whereas all the existing frameworks keep all of the internal state, in private data structures that you don't have access to. Now, the last thing we aim for is that if you download a piece of code, then my philosophy is that you better execute all of it. If you've downloaded a piece of code and part of the code didn't get executed, well, why were you downloading it? Clearly, it's the code you don't need. So let me give you an example of that, right? Typical component has both the rendering information, what does the component look like, and all of the event listeners for it. And if you want to re-render a particular component, you have to download it. And you don't get a choice to say, I only want the template stuff, but not the listeners. You need to download everything. And so you're downloading a whole bunch of code that you never need. And so let's say one of the buttons you have is, send a message to customer service or something like that. And most people never click that. Nevertheless, you have to download the code and you have to download all of the dependencies that go with it. And there's no way for you to kind of separate these things out. So one of the things that Qwik aims for is to say like, no, let's separate all this stuff out. Listeners about what should happen when you interact with the component is different than how the component renders. And me interacting with the component is different than me re-rendering the component. And the two shouldn't be tied together, because the moment they are, you end up in this situation where you just get too much code available to you all at once. Okay, so I think this is a good point to kind of give a demo. If I can figure out where my, okay. So here is a standard to-do app. It's a very trivial and simple app, but I think it is useful to kind of demonstrate how the thing works. So is the font big enough? People can see? Yeah, okay. Okay, so I'm gonna refresh the page and let's go to performance and let's record it. In a few seconds, it should notice that nothing's happening and it should stop, hopefully. Come on, Chrome, you can do this. No? Okay, I'll stop it for you. Okay. And where is it? Why is it not recording? Let me try this again. Oh, right, because oh, sorry, I'm clicking the wrong button. No, really, I know how to use a computer, I promise. Now it's gonna stop. Yes, okay. All right. Oops. Okay, so here's your request, right? On a server, you asked for the page for you to get HTML out of it. The thing that's kind of is unique here is that if you look at scripts, it actually shows 0 scripts. No, that's not true. Here we go. Where are we? Scripts. Okay. if you look at all the code that executed here to get the page up and running, we're talking 0.2 milliseconds, 0.2 milliseconds, and 0.1 milliseconds, so 0.3 milliseconds, right? It's nothing. Like there's no way you're gonna get React or Angular or Vue or whoever to bootstrap in under a millisecond. It's impossible. And the reason it's impossible is because the amount of code that has to execute, right? The amount of code this thing executes is essentially here. Pretty print. It is, where is it? Right, it's down here. This is it, right? This is the 1 kilobyte that we have to actually inline into the page to kind of get it running. And all it does is it sets up a listeners, global listeners for us to do. So that's the first thing. Let's look at the networking tab. So the first thing you're going to notice is nothing downloads, right? There's no code to be downloaded because the only piece of code that we have is actually inline in the index HTML. So there's nothing in the networking tab. When I hit a key, what? Okay, sorry, I don't check this. Oh, here we go. Let's try this again. Right. So the only thing we download is, let's just do JavaScript. Right, nothing here. Like hit a key, and it starts downloading a whole bunch of things. So me hitting a key on a particular input tells the system like, oh, I have clicked on header add to do, and because of that, I had to download that piece of code. But also, the whole, it's not just a piece of code itself, it's also the framework, right? And the framework is fed through rollup, and rollup decided that, the best way to cut it up is into these multiple chunks. So you see this bunch of chunks that come up over here, and together it downloaded, oh, this is non-minified, I see. Together it's like 200 kilobytes, but it's not minified, so that would be better. The cool thing about it is that we should be able to do coverage, yes. Oh yeah, here, click like this. Okay. And we do just JavaScript. Okay. Here is the thing that we talked about earlier, is that if we download code, I want the code to execute. So at the very beginning, we inline the bootstrapper that's less than a kilobyte, 963 bytes. And you see about half of it got executed. But the moment I click on something, almost all of the, let's see where it is here, almost all of it gets executed. And one of the things I want to show you is that the chunks that downloaded, the red is the part that didn't execute, right? So the chunks we have downloaded, almost all of the code that got downloaded actually executed. And that's kind of what we want, right? We don't want to be downloading code that it's unneeded. And so one of the property we look at is like, hey, if you're going to bother downloading a piece of code, make sure it's executed. Now this actually continues. So, I type a bunch of code, I hit enter. Again, more code downloads and more code executes. And if I go and decide, like, let's go to the tab again. Let me clear this. Type, enter, right? Whole bunch of code downloads, as you can see over here. As I interact with the page, more code is downloading and more code is executing. And this is kind of the key thing of Qwik, is that we really want to focus on the amount of code that we download. And what you end up with is a world where the amount of code that you have to download and execute is proportional to the complexity of the action that the user performed, right? So if the user did something simple, the amount of code you download is simple. If the user did something complicated, then obviously you have to download more things. Whereas in regular application, the code is proportional to the size of the app overall, right? And there is no easy way to break up the app. Now, all frameworks basically say, like, of course we support lazy loading. It is up to you. You can use your dynamic import or whatever you have, right? But it turns out in practice that doesn't work, because the framework's render method is fully synchronous. Because when you have a component and a component imports children, then you automatically have to pull those children in. And because the component has Qwik listeners, those Qwik listeners have to be in line, and they import more things, which you have to have, and so on and so forth, right? So while in theory, existing frameworks are compatible with lazy loading, existing frameworks don't make this easy. And in practice, almost nobody does it, right? The only lazy loading that really exists in frameworks are on the route level. Like, if I go to a different route, I will download that piece of code. But there's really no way to take an existing page that the user has and break it out into smaller chunks. Like, none of that stuff really works. And one of the things we discovered is when we were implementing the rendering system, is that the rendering system had to be fully asynchronous. because as you're rendering the page, at any point, you can come across a point of asynchronicity where you have to say like, well, actually, I don't know how to render this, but I know where to get it from. And so you can go out, download the code and continue rendering. So one of the big things you need in order to enable this kind of behavior is fully asynchronous rendering. Something that, as far as I'm aware, no existing framework has. All framework rendering systems are fully synchronous. And when you're fully synchronous, what you're really saying is, I need to have all of the code available ahead of time. And that's where you get yourself into trouble. Okay, so let's kind of go into deeper to see how this works. So here we have this input. How does it know to do all the things we kind of described? So here I'm going to zoom in on input. And one of the things you're going to see here is that we leave behind a annotation and as a form of attribute. We're saying on : key up. And if you hit a key up, then I want you to download header at to do and then pass some parameters to it. So you can think of this as a function call, right? You can think of it as, hey, when you click on this button, or you in this case do key up, I want you to go download this piece of code and invoke it with additional parameters, which is like, looks like a target value and the code. And this is what I mean by serializing the state of the framework into the DOM, right? All of the information that is needed about this particular thing is in the DOM. But let's go further. So if you go up, you will notice that this says declare template. So this says that if for some reason you decide that this particular template needs to be re-rendered, you can download it at this location. And not only that, the component will probably have some internal state. Sorry, people are squinting. Is that better? Or even more? How's that? Okay, so one of the things that happens here is that the framework has internal state, right? So when you want to render the template, it's not enough to just render the template. You also want to know the component instance. And so the component itself is storing its state inside of the DOM over here. But in the case of a to-do, right, you have like 4 of these things over here. If I type in a new item and hit enter, one of the things that has to change is the 3 has to become 4. And also I have to re-render this particular thing over here, right? So this item gets added and the 4 changes to 5. And so the framework has to understand that as well. And if you go a little further up, you'll see that we are serializing that information as well. So we're serializing it in to-dos and also items. So think of it like a database. So you're saying there are to-dos entity and there's item entities. And in this particular case, let me refresh this to make it even clearer. We have a to-dos 1, 2, 3, 4. I just made up a key 1, 2, 3, 4. And it says the completed and a filter and items are item 1, 2, and 3 in here. It's all serialized in there, right? Also, it says item 1 is completed. The title should be read quick docs. Item 2 should be this, and so on and so forth, right? So the state of the application is fully serialized in the DOM. So when the application wakes up and wants to continue, it doesn't have to talk to the server or anything of that sort. Like all of the state that you need is available to you. Now, when we have the state, there's a difference between I am a component and I just want to render myself, and I need to know, well, let's say you're this particular item right here, and I want to render just the profit line. All I need to know is like, hey, what's the text and whether I'm not clicked or not. And that's very different than I am going to click on this button, in which case I need to actually download the mutation behavior of the item. So Qwik can separate the concept of like, oh, I just want to know how to render the state. So I just want to state no methods are required at this point. So just give me the data. Or I am clicking on it, in which case I'm going to run some behavior. So now, not only do you have to download the state for me, but you also have to download the behavior, which knows how to mutate this particular state of the component in it. And so these are the kind of primitives that other frameworks don't have. And because you don't have them, you end up in the world we end up with. And so my point is that I think a framework that can do this also has to provide these kinds of primitives. Now, let me show you another interesting thing. One of the problems that existing frameworks face is that if I type in here and I hit enter, how did the framework know to re-render this item here and add item here? The answer, if you're in React or Angular, is, well, just re-render the whole application from the root. But re-rendering the whole application from the root requires us to download all the templates, which is the very thing we're trying to avoid, right? So we need to have a different way of doing it. And so the answer to that is that you need to have a reactive system. You need to set up information that says like, this data is attached to this component. So if I change this data, then this component has to be re-rendered so that we can bypass all of the other components and not having to bring the whole application down, right? Now, such systems exist. For example, Svelte does it that way. These are called reactive systems. The problem with Svelte or fully reactive systems is that you have to set up these pipelines. You have to set up these hooks that basically say, oh, this code here has to have a subscription. This component here has to have a subscription to this code. And when this code changes, the subscription gets fired and the subscription listener goes and does the work. And setting up all these subscriptions requires downloading code, and we're back to square one, and we can't do that, right? And so the way we solve this is over here, we know that we have to-dos 1, 2, 3, 4. And so one of the things we can do is we can ask DOM. All of our state is in a DOM. And the way we do that is we say document query selector all, and we say, hey, give us all the components that have are bound to to-dos 1, 2, 3, 4. And notice what it does. The query selector says, yes, I have 2 of these components. I have this one. This one needs to know about the to-dos because that is rendering the list right here, right? And of course, the footer also needs to know about the list because there is 4 items over there as well. And so the framework is able to figure out without having to execute any code and without actually having any information, all the information is in a DOM. The framework can figure out like, oh, if you modify this state, then these other components also have to be updated. We come to this particular components, for example, the footer. And in here, the framework can figure out like, okay, to update this component, you need to download the main template. And also, I'm going to need the state associated with to-dos 1, 2, 3, 4, as you can see over here. And so that is how we are able to take the large application that you have and decompose it into tiny little pieces and make sure you should download only the piece that you want for the code. Questions? Yes. Mm-hmm. Okay, so that's excellent question. So now we're getting into the business of prefetching, right? So the first question, and I really mean the first question anybody was asked, basically they say like, but wouldn't you have a bad latency on the first interaction, right? Every time I click on something, I'm going to download a whole bunch of code. Okay, so now we get into the business of prefetching. Prefetching is super complicated because the way the Google page speed rank works is that if I just list all the script code at the beginning and I start prefetching it, this actually counts against you. The Google page speed is not smart enough to understand the difference between, oh, I'm just prefetching a list and that really is not important whether it happens or not, versus I'm actually downloading and executing the code. And so you'll get penalized in both cases. So the way we actually do this, or the current thing that we're trying to solve, is that in addition to the little tiny 1 kilobyte hello world, there's additional piece of code that optionally you can download, which is a prefetch script. The prefetch script is on the order of 300 bytes, super tiny, or maybe 500 bytes, something like that. And what it does is it creates an intersection observer for the page. And for the page that's visible, it looks for all of the on-colon properties, right? So it looks at it and says, okay, so I know that your input is visible, and I know that the input has an on key up, and therefore I know that the developer, the user could, in theory, type over there and cause that event to happen. I also know there is event listeners on all over these places. Over here, there's the X's and so on. And so you can collect all of this, the full set of things that exist in the system that the user could potentially click on. The stuff that's below the fold, user can't click on because it hasn't scrolled over there yet, right? So when you do this intersection observer, you basically get a list of URLs. And what you do is you take these URLs and you ship them over to a web worker and you say, go fetch them. And because it's on a web worker, it doesn't get penalized against you. Like that is just not part of your execution model. And as far as Google page speed is concerned, it is, it doesn't matter what you do on a web worker. It's a separate thread. It doesn't matter. So on the separate thread, what we do is we start going after these URLs, start fetching them and downloading it to get the cache warmed up. And not only do we do that, when a server sends it across, the server actually looks at the import statements and says, oh, I see that you're downloading this, but that will, because there's an import statement, will also download this other thing. So there's a way to insert a special header into the response that says, oh, by the way, also prefetch this other URL. And so from those root set of URLs, you can send this across. Now, the other thing you can do is that the server can actually keep statistics. We don't have this implemented yet, but one of the things we're thinking about. And the server can know, like, the most likely thing you're about to click on is this thing. So we can prioritize the order and we can start downloading it. You're probably going to click on the button over here first. So we're going to push all the code that first and push all the other stuff later. The end result is that we can push all the code to the client. The only thing the client has to do is to execute the JavaScript. It would be better if we could actually use prefetch for module prefetching. However, as of right now, you get penalized for it. So we do it on a web worker. The reason why it'd be better to do module prefetching is because you can push code to the browser, and the browser also will parse the JavaScript, but not execute it. So you can get it really ready, but just don't execute. These are all tricks we can do. If browsers get better, it would be a way for us to tell the browser or tell Google PageSpeed, like, by the way, we need these URLs, go start fetching them. But really, they're not part of, there's nothing to execute over there. They're not really part of it. So please don't count it against us, right? Like it's just not fair, really, right? Because we're not running it yet. I'm assuming that one day Chrome will add such API, but as of right now, such APIs do not exist in the browser. And so our workaround is to collect what you see, ship it to the web worker starts fetching. That doesn't count against us, but because it starts fetching everything, the caches are fast. And so when the user clicks on something, it's instantaneous. Not the same action. So here, the first time, let's refresh. The first time I hit a key, right? A bunch of things download. Once I type more, nothing more downloads. The code is already downloaded, right? Nothing downloads, right? Now, when you do the next action, when I type and I hit enter, now I've performed new stuff. Piece of code that didn't exist before. And so now we download even more code, right? Because now the action is to add it here. Now that's one thing that I want to point out. Hey, let me show you something else that's I think super important. When I refresh the page and I click on a button over here, the first thing it downloads is header add to do. However, if the first thing I do is I delete something, then it starts with item remove. When I maybe click here, it's does yet something different. The point I'm trying to show you is that there isn't one central way to bootstrap your application. There is infinitely, well, not infinitely, there is as many ways as there are listeners in your DOM. And that's kind of unique, right? Because we tailor the bootstrapping process to a specific interaction that you're doing, we can really focus and get a really tiny amount of code to be downloaded and executed. Something that, again, other frameworks cannot do. So when I look at the way existing frameworks are built, to me, they're built from this mental model of like, oh, I'm building a desktop application. All the code is available. I just have to make it run fast. And I think that's a wrong mental model for the browser. And we have pushed this mental model as far as we can. And the result is this, that the industry, like this is not a cherry-picked set where I'm just not liking Gap or whatever, I'm picking on them. You can go pick any kind of website, run it through Google PageSpeed, and you will most likely get a red score. You will rarely get a yellow score, and you will find no websites that have a green score. As a matter of fact, if you take Google's own website, google.com, and feed it into PageSpeed, you'll get like 70. So my point here is that the existing mental model, the existing frameworks and mental model are forcing us in a direction that naturally end up with this. And no matter how much you fight with this and how much you're going to spend time trying to make it go faster and faster, you will maybe temporarily succeed, but very quickly you will regress. And I think for people who actually build websites, like I'm speaking to them, they're shaking their heads like, yep, that's exactly what happens, right? There's a second part to this particular bit that we haven't talked about, which is that user tracking. So scripts that keep track of like how many times people visit you, etc. Those also count against you, and they cause a lot of havoc. And just adding that script alone will drop you a couple of points. And because we want to have 100 out of 100, we actually cannot have the tracking scripts in the main thread. And so we're working on a way of running them in a web worker. So you still have them, you can still have all these particular things, but they got to be on a web worker, because if you put them on the main thread, you're going to get penalized, right? And our goal really is to have 100 out of 100. And as long as you have this attitude of HTML first and JavaScript later, you should be okay. However, all of the existing technology is the other way around. It is JavaScript first, maybe HTML later. And this is the problem we have. Sorry, good question. Sorry if I went too deep on it. Okay. Okay, so this is To-Do. To-Do is a standard. There's a to-do-mvc.com you can go to, and it's the same exact app written in every single framework you can imagine. You know, and all these frameworks claim like we're faster, with faster. It's kind of fun. So it's kind of a standard thing to build. They give you a standard set of CSS, a standard set of templates, a standard set of everything, and they say like, okay, just rebuild it in different frameworks. So the idea is that you can go there and you can say like, well, which one do I like better, right? And so this is why I kind of rebuilt the To-Do as a standard thing to kind of show off all of these properties. Yes, it's a trivial application, isn't going to help you, but it kind of shows off the main points of it. One of the problem with these To-Dos is that you can have a quick or fast application startup with any framework if it's small, right? But as the application gets bigger and bigger and bigger, all the existing frameworks are going to get linearly penalized. Whereas Qwik doesn't care how big the initial HTML is. It doesn't matter how complicated your app is. Qwik just doesn't care because it's a constant pay that you pay. The other thing that Qwik can do, which I kind of didn't mention, is when you normally do SSR, you have to download the full HTML. And if you get a large website, and there's many websites I'm sure you visited where you just start scrolling and it just goes on forever, right? You just keep scrolling and scrolling and scrolling, right? You know what I'm talking about, right? So these websites, they'll get eventually penalized because you're downloading too much HTML. And if you take these websites and you feed them into Google PageSpeed, you'll actually get penalized, not because of the JavaScript, but just because of the ridiculous amount of HTML you're actually sending through. Now, one of the things that Qwik can do is because Qwik is stateless, right? The framework itself has no internal state. All of the state it contains is in the DOM in form of these attributes that I showed you, whether it's a listener or state or where to download a template. Everything is in the DOM. Nothing is stored inside of the JavaScript heap as it may. And this is what allows us to, at any point, just snapshot the HTML and ship it to the client, and we can continue. One of the things you could do if you have a super long page like that is you can just ship HTML that's above the fold, right? Just send the beginning, the person immediately sees it, and set up a scroll listeners. And as soon as you start scrolling, you download the remainder code and you put it down as an inner HTML. It's a super fine operation. It's just an inner HTML. Now, here's where the difference is. Existing frameworks, you would have to somehow rehydrate or rerun this thing. Like, I don't even know how you would get additional code and tell the existing framework, like, oh, I downloaded this extra HTML that I inserted over here. Now you have to kind of just deal with it. But with Qwik, because it's stateless, it doesn't even know you did that. And it's only when you interact with that point does it discover that you have some URL over there and you need to run. And if you have prefetching, if you start scrolling and you inner HTML the child to it, and once the page gets scrolled up and shows up in your view, the intersection observer wakes up and says like, oh, by the way, I've seen now new things that the user could interact with, and you can start prefetching that stuff ahead of time. So you can get a really nice and interactive site. the point I'm trying to kind of explain here is like, this is fundamentally different approach to building your website. Like if you know how to build existing websites, this is just like alien technology. It's just different, right? Like everything is different. Nothing's the same here. Yes. Okay. So you're, I think what you're saying, I want to see some code. Okay. Let's talk about code. Okay. So is the font big enough? Zoom in. Yes, I can. How's that? How about the, oops. No. Can I close this? Wait. No. Okay. Here we go. Okay. So the way traditional application is built is you bring up like index.html, and then inside of index.html, you live like a div and you give it an ID. And then somehow you bootstrap a framework and you say like, oh, this component is really this div over here, right? Like whether it's React or Angular, they all work the same way. The thing with Qwik is that there is no bootstrap or the element, like none of this stuff makes any sense for Qwik, right? And so one of the things you realize that when the server side renders, you start with basically HTML. And so this is JSX because it's kind of the standard these days, right? And the JSX starts at the very root, and you just start rendering from the very, very top. And you say, I have HTML, I have head, I have title, links. There's this thing called Qwik protocols, which I'm not going to get into too much. But then you just insert your to-do app. And at the very, very end, you say, go insert the Qwik loader, right? That's the set of things. And then you have to give it a set of events that you want it to listen to. And then whether you want the debug version or the minified version to be sent across. And so this is how you do it. So let's go at the first, let's zoom into to-do app. No, actually, I want to go there. Okay, here we go. So if you're familiar with JSX or React, it should feel very natural. The problem is that what you really want to put over there is you want to be able to, here, let me get this up and let me get to-do template. What you really want to refer to is this thing right here, right? You just want to say like, the to-do is that thing over there, right? This is just how you would do it in React. The problem is if you do a direct import, you will cause, every time you do a direct import, you make it harder and harder to lazy load stuff. Because what you really want to say is like, I don't know, when you render, when the rendering starts, here, let's start with, here we go. So when the rendering starts, you say, render this, right? You go through HTML and the rendering does its thing. It comes through to-do app, and the rendering system has to make a decision. Do I descend into the to-do app or not? Now, all existing rendering systems always descend. Because they always descend, there is no way to prune the render tree, right? You're rendering the whole world all the time. But one of the things we want to make sure we do is that we can render individual components separately outside of the whole tree that exists in the world. So rendering system, when it gets to the to-do app, it has to make a decision. Do I descend or not? Now, in this particular case, the answer is yes, because you have never seen the to-do app before. And so the first time you see something, obviously you have to render its content. And so the render system goes into the children. Now here, what you really want to do is you want to just have an import to this function right here that contains the pieces of code that has to go there. The problem is, if you do this, then you will forever be statically linked to that child component. And because it will be forever statically linked, it will be impossible for you to render the parent without also, maybe you can not render the child, but you will certainly download the child, right? And we want to make sure that doesn't happen. And so we have this intermediary file, and all of this file does is instead of having the import statement that you see here, in this location as a direct import statement, we really put it as an import statement in here. Now, this is a first version of Qwik. And so these QRLs essentially are dynamic imports that get serialized into the HTML. You can think of this as an import statement that should go here. But if I put it there, it's permanent, and I don't want that. I want it to be dynamic. So I'm moving it from this location into this location. So this facade is kind of what enables this magic. However, we don't want to write this facade. And so we are working on tooling right now where you don't have to do this. You can just directly import the component that you want. And as long as the file name that you're importing is of the correct thing and it has the export in the correct incantation, we will automatically generate this intermediary file so you don't have to worry about it. So the whole thing then just repeats, right? So you are now rendering, you say, I want to render the section. And in the section, you can basically render what we call entities, where you say like, by the way, I want you at this particular in a DOM tree to say that there exists this thing called to-do entity and item entity. Again, think databases, tables are and rows. Basically, we have a table called to-dos and a table called item, and a particular row inside of the table is either the to-do entity or the item entity, and there's a foreign keys between them, like all database stuff that I'm sure you're familiar with. Okay, what this does is it basically says, look, if somebody asks for a particular item, this piece of code needs to handle it. So the way to think about it is somewhere down in the tree, some component says, I need an item 1, 2, 3, 4. And that event bubbles up over the DOM and it comes across here and it says, ooh, I know how to provide you with 1, 2, 3, 4, item 1, 2, 3, 4. And so I go into the item entity and in there, you basically execute this piece of code that knows how to do this. So that's what this piece of code over there is. Then, I'll say, I want to have a header component, main component, and a footer component. And again, if we look at the main, we will see the same exact thing, which is that there is this intermediary which creates this facade so that this QRL, this import statement can go across. Again, this piece of code will not exist, hopefully soon. We're working on getting rid of it. And the result is, let's see, main template. Oops. The result is, we execute this piece of template for it. We can ask for things. So here, this is where we're asking for our to-dos. We're saying, hey, I need to-dos to do my rendering because I need to have the list of things because I'm going to have to do, the standard, I have to iterate over the map of all my items. And for each item, I'll have to create an item subcomponent and I have to pass the ID across it. So this is how you basically say, go get me the thing. Don't worry about the exact syntax. The point here is that the component needs to tell the framework in a DOM serializable way about what it needs. Because if it's not DOM serializable, if two components have some secret way of communicating, the framework won't know about it. And if the framework doesn't know about it, it won't know to wake up a correct component and so on. So we have to be really strict about like the way you talk to the outside world are through these well-defined, patterns that the framework understands. And those patterns need to be serializable into the DOM. So at any point, we can freeze the application in a DOM and send it across. So the way this SSR works here is that we just run the code in the server. We wait until render is finished, and render is fully asynchronous. So there's, server can go fetch data and can do all this stuff. At some point, it's fully finished. Once it's fully finished, we just serialize the HTML by, going to the document.innerHTML at the root. We take that HTML, ship it to the client, and we're done. Right? There's nothing else to it. And it's kind of a trick. So that's kind of how the code works. So let's look at the button. I want to show you one more thing. Oh, here we go. Here's a button. Let's see. No, not this button. Header. So here's a button where you have input. You have the on key up. And again, we have to leave behind the QRL. This is basically the import to where the behavior is. Again, this will go away. We're just going to have a real import to this particular thing. And provided that the real import is of the correct format, etc., the QRL will be generated automatically. So think of QRLs as imports that exist in a DOM. And hopefully you won't have to write them. Like our goal is to have enough of a developer experience tooling where these things get generated automatically, but it is the thing that kind of ties the thing underneath. And what you end up with is a code where these QRLs exist in here, right? They exist like either as a template or they exist as an input. If I go here, and exist as the on key up and so on and so forth. So hopefully that answers the question of like what the developer experience is like. It's very, JSX is kind of the standards these days. So instead of inventing yet another templating systems, we're doing that. The other thing I wanted to point out is there's lots of frameworks outside. I don't think, there was a kind of a golden age when AngularJS started because there was no existing frameworks. And AngularJS was filling a need that existed and no existing frameworks existed. And so I think that's the reason why Angular became popular, is because it was the first framework that existed in this niche space and nobody else had it, right? And then after AngularJS popularity, other frameworks came in where it says, oh, we have clever ways of doing it, React, Svelte, and they all add clever things. I think where we are in the world right now is that there really isn't space for additional framework. If you look at like Svelte has a lot of cool things that are better than React. And yet its popularity is not that high. It's not really winning. And the reason is that I think the additional benefit that you get from switching just doesn't justify the fact that the React kind of owns the space right now. So my point here is that if you're going to become a framework, you can't just be a better framework. You can't have an incremental improvement on this stuff. You need to like fundamentally change the game, right? Otherwise, you're just not going to win. Like you can't just build a slightly better thing. It has to be a thing that solves a problem that cannot be solved in existing technologies. And so Qwik is this thing, right? Qwik is, how do we get this amazingly fast time to interactive? Because we know it matters. All the companies care about this. They're all trying. They're putting their best engineers on this particular problem, and they're all failing. And my argument here is that they're failing is because the fundamental approach of these technologies isn't conducive to get this thing right. And so if you want to get this thing right, you have to look at the problem in a very, very different way. And this is a different way of looking at it. And so I think Qwik just kind of changes the game in the sense that like it says, look, there's this completely different way of looking at it. We serialize everything inside of the DOM. DOM is the answer to everything. And I think it will be yet another one of the big things where we are redefining like how we do and approach this. And I'm sure, in a few years, there's going to be different people who are like, oh yeah, with this time to interact, we should really pay attention to it. And I'm sure there's going to be new frameworks that are going to be coming out and they're going to be focusing on this particular thing. But as of right now, I think Qwik is the only one in this particular space that actually looks at this problem and says, how do I design a system so that this problem can be solved? I think that's what's unique about it. Other questions? Okay. Okay, so I lied to you a little bit. We don't do everything in the DOM. The way it works is your mental model is pretend that it's the case, and at any time you can call a special function called serialize to DOM that takes everything and sticks it in there. But normally we don't do that. So normally the framework is stateful. It understands a lot of things about it, and it is intelligent about like, let's not write things into the DOM unnecessarily, and all that stuff happens. But at any point you can put, you call a function called serialize, and the framework can take all the information it has, push it into the DOM, and says, okay, now you can take me and turn me into HTML and send it across. So let me show you. When the thing, maybe you've noticed, when you look over here at to-dos 1, 2, 3, 4, it has a JSON attached to it. But when I start mutating the code, the to-dos 1, 2, 3, 4 loses its JSON, right? Instead of having the wrong JSON, I'm just going to delete it. And from now on, if I keep changing it, nothing happens here. Notice item 4 and item 5 got added over here, and I can go and mutate another item, and notice how it's slowly removing all of the state that was in here. At this point, like all the state is deleted, but I can call a function to restore it all so that I can serialize it. I can also just find it in here somewhere. Give me a sec. I go to section, if I go to properties, injector, here we go, here's our entities, and I can get all the stuff that I need from here. So we're intelligent, we don't put everything in the DOM all the time. But the point is, we can easily call a function or push a button and bam, it's all in there. And then we can serialize it and send it across. So the way to think about it is that the Qwik is stateless, but we can cache a lot of stuff internally so that we can be faster. Mm-hmm. Right. Uh-huh. Selectors are pretty quick because they have to be because of CSS. So if you would have performance issues with query selector, you would also have performance with CSS that you have in your system. The other thing that I want to mention that I think that is a big difference between this and something like React is that React has no choice but to diff the whole application at the root, and the whole tree has to get rediffed, right? We don't need to re-render either because we have all the caches, right? So in that sense, we're the same. The place where we win is that React has no choice but to go to the root and render the whole thing. This thing knows how to render components individually and out of order. What I mean by individually is that a component has a parent and a child. In the React, first of all, you will always render the children. There's nothing you can do about it. And I'm going to say that you have to start with the root because when you mutate the state, you don't actually know which component might be reading the state. And so the only sane thing to do is to start rendering from the top. So here, because we know what component is component to where, which is the connections, we can just see like, oh, we only need to re-render this component and that component. And again, think of it for the purposes of e-commerce websites. When you have a large page with lots of content, there is only very few components on that page that actually could change. Rest of them is just dead weight that React doesn't know how to deal with, and it will always have to re-render, etc. And our personal experience actually tells us that the rehydration and re-rendering of these large VDOM trees are a problem. React knows this as well. That's why they're trying to they have this thing called threads or resumable or whatever that they keep talking about, but they never actually released, because it turns out that if you change the rendering pipeline for your application, none of the existing code will actually work. And there's good reasons for that. Why not? Because you're just changing the semantics too much. You can't just do it. Anyways, those are all the differences. Why it's not. I think the reason why this is in the end faster is because it has less work to do, right? Because it doesn't have to redo the whole application system, right? It is focused, saying like just this component. I can always take a component and break it down into smaller and smaller chunks and narrow the amount of work that has to be done. I love hard questions. Yes.
What are some of the disadvantages compared to React or the other frameworks that you might have encountered while working on this?
Yeah, that's a good question. The biggest thing is that you have to look at the problem in a different way, right? If you take an existing developer that has, like, oh, I just put HTML or whatever, JSX, and I attached listeners and and in function, and it uses the closure to download, like that kind of developer will be surprised, because like, well, you can't do that, because if you do that, then the closure always has to come with the template. That means you're downloading code that you don't want, and there's no way to separate it out, right? And so you run into these kinds of problems. So I think the biggest disadvantage is you need to reprogram developers' minds to think about the problem in a different way, right? And that's a big thing. That's not a trivial amount of thing. The way I look at it is that's both a good thing and a bad thing. It's a bad thing because like what I'm showing you here is kind of very different, so different that there is really no way to just take an existing app and like somehow get it to this state, right? It's significantly different. Although we are trying to figure out ways of being compatible so that you can use this kind of like an outside shell, and into it you could load like smaller React components or Angular components or Sweat components, so that we can become more of like an orchestrator of things. But that's a separate discussion. The real problem is that you have to reprogram the developers, and that's both good and bad. And the good part is that because it's such a fundamental different way of doing things, there is no way that existing frameworks can catch up in a sense like, oh, I'm just going to add a bunch of features and become competitive. There's just no way to do this. I actually know because I was on Angular team and I was trying to figure out how to get Angular into this state. Like I've been thinking about this thing for the last 3 years. And my conclusion is that there is just no way to take an existing framework because you would have to introduce so many breaking concepts that you essentially would just end up with a whole new framework. And so what that means is that if this text takes off, it has a niche to itself, right? There is no way for existing frameworks to be like, oh, let me add some features and become competitive with it. It just can't happen. So in that sense, you're defining a whole new space that didn't exist before. And with it, you're inviting other frameworks to become competitive by creating something else and different, but you can't have existing frameworks to somehow morph themselves into this particular problem because it's just not going to work. So that's a kind of a nice thing from a competitive advantage. It's also a problem because you can't just go to existing teams that have existing projects and be like, yo, use us, kind of requires a rewrite, etc. However, this is where Builderio comes in. Actually, this is why I kind of went on a tangent. The reason why I work for Builderio is because Builderio has content management system. And what the Builderio allows people to do is, the engineers go create a whole bunch of components, whether it's React, Angular, Svelte, it doesn't matter, like any of the components. And then these components get registered with Builderio's editor. And then the marketing department can go and like put the components in and then say publish. And what happens when you hit publish is we look at the structure that the marketing component did, and we actually look at the technology you have, like if you use React, then we go and generate a whole bunch of React code so that the whole thing can be plugged together and so that it's canonical, so that we don't introduce some other thing that you don't have in your system. So if you're a React shop, then what we generate is React code. If you're an Angular shop, we generate Angular code. If you're a Svelte shop, we generate Svelte code, right? And so by doing this, we can we basically say, like, if you build a website with Builderio, we can generate anything you want. And because we can generate anything you want, it's easy for us to come and say, let's generate Qwik code. And you go to existing customers and say, I hear you care about the speed of your website. We have this new technology called Qwik. There's a button over here. You can push it and we'll generate Qwik code for you. And we will do some magic to kind of wrap your existing components. Like, as I said earlier, that we want Qwik to be the orchestrator and it can go in and call in your React component. So if your shopping cart is in React, we'll bootstrap it in there somehow, through some fudge factor. And because it's in Qwik, it's going to have these amazing performance metrics. Would you like to push that button, right? Like, which marketing department isn't going to be like, oh yeah, let's not push that, right? And then they'll go to their engineers and be like, everything about this website is amazing, except this shopping cart, because it's written in React. Anyways, that's my evil plan for taking over the world. It depends what you mean by production. This is still new. One of the things we are trying to do right now, we are building this for us. Right? This isn't me going out and building another framework because I think I love the world and I want to build a framework. No, this is building this for us. And I kind of told you what our goal here is. Our goal is to take our existing customers and move them onto this technology and have amazing time to interactive so that people that run on top of Builderio can get 100 out of 100 on their production websites. And then because they get 100 out of 100, they'll get higher scoring on Google page sizes. So if you search for shoes, and there's 2 companies that sell shoes, and one of them is 100 out of 100, the other one is 30 out of 100, the 100 out of 100 is on top. And if you're on top, more people will click on you. And when they click on you, you can serve them really quickly. And because of that, you'll have higher sales. And so you go to a customer and say, like, look, if you use this technology, you'll just be amazingly quick, amazingly high on your conversions. But who's going to say no to that, right? Right. Yes. So, but we also are open sourcing this and saying, look, this is the technology, this is the magic behind all of this stuff. You are welcome to use it as well. But the big difference is that when I built AngularJS and Angular, I kind of built it in a vacuum saying, like, I think it would be fun if this existed, and I kind of built it, right? So kind of the ivory tower approach. And I always joke that I actually have never built an Angular application, which is kind of embarrassing. The big difference here is that I'm not building a framework just for the sake of building a framework. I am building it because I have a specific business goal that I want to solve. And I want to do it in a way where it's open source and the outside world can use it. But if you don't want to, you don't have to. This thing is going to be useful and successful on its own. Either way. But I think what's going to happen is that once people start migrating onto this, and once everybody else will see that that other website is getting amazing scores and it results in high conversion rate, the marketing department will go and scream at the engineers and be like, we got to do this, right? And so it's going to be a very different function. It's not going to be about like what framework you like the best because you think that this syntax is prettier or that syntax is prettier. It's going to be a debate about like, no, we need to get this performance metrics. You're welcome to use any framework you want, but you're not going to succeed for all the reasons I listed with all of the existing technologies. So you better start using this. I think there was a question here, and then we'll go over there. Yes.
I'm thinking about the rollers or spinners. For example, when you hit the button and you want to see that something is loading, for example, when the connection is bad or you're at the subway or something, it seems like it's kind of impossible in the framework to do because when you hit the button, you got on something, and then I get to know what should be changed. But what I want to do is to display the spinner or the roller before I just start the roller.
Yeah, so this is where the prefetching is part of the answer. It's not the whole answer, it's part of the answer. That's a good question. I'm going to add that to my list of things to think about and making sure that we can do this. We are at the stage, you asked me if it's production ready. We are at the stage where we're trying to get our own homepage on it. We're close. I'm hoping that my original plan was the end of the month. It looks like it's not going to happen, maybe another week or so. But we're pretty close to have our own homepage basically running on this thing. And the idea is that we want to then push out and get more and more of our stuff. And as we're doing this, we're going to learn and we're going to run into these kinds of issues and solve them. So production ready means like, well, I don't know, how much of an adventure do you want to have? Because I think a lot of things will change. Like, for example, there's these QRLs everywhere and everybody that sees the QRLs is confused because like, I don't ever see the QRL. I've always just do an import. I'm like, yeah, but the import you can't do because it's static. I need something dynamic. And you can't do dynamic import because that's in the code and I want it in the HTML. So I need a serializable representation of a dynamic import, which is what QRL is. And so one of the things we got a lot of feedback on is it's confusing. And so one of the things we want to do right now is actually add the tooling so that you don't have to worry about QRLs. You don't have to ever write them, but the tooling automatically produces them for you, right? So we are kind of in this mode of trying to make these things better. Spinner is actually one of the things we've been discussing a lot about all the constraints that go with it. For example, if you are server-side rendering, you don't want the spinner, like, because when you're server-side rendering and you're waiting for some data, like rendering a spinner is pointless, right? Instead, you just want to say like, no, I'm not ready to render this particular bit yet. Please wait a little longer. When this thing is done, I will finally render the correct thing. So you have to write these components in kind of a way where you say like, am I on a server? Yes or no? Because if I'm on a server, then I'm just going to wait for the thing to resolve before I render. Whereas if I'm on the client, then I got to render something to let the user know that I'm working on it, and then I will render the actual thing. So these are all good questions that are to be figured out. Yep, Node.js, nothing special. So it renders on a node using Domino. This particular demo over here, it takes about 50 milliseconds to render. That's not how this actually works in production. In production, we render it and we we push it to CDN. The result gets pushed into the CDN. And this is where the beauty of this thing comes in, because CDN is just, piece of HTML. And because the application just resumes where the CDN left off, one of the things we could do is we can push multiple copies of it. We can say, okay, this is a website that sells shoes, but we will push a shoes for like, if we don't know who you are, Then we're going to push shoes for women's shoes, and we're going to push shoes for men's shoes and for children's shoes, right? And by having multiple sites figured out, we get a cookie, and then we say like, do we know who you are? We don't. We just do a generic site for you. If we do know who you are, then we can, push some different one. And because there's no, you can essentially run it once on a server, compute the state, and then resume it multiple times on a client. Yeah, you can certainly do that. So this would be a standard application. So now we're talking more about like classical websites, like rather than e-commerce websites. We primarily focus on it in e-commerce. In the classical websites where you have an app, you could certainly just run it on a server side. You would get a request, you get the user, everything in there. You just don't have a CDN in there. You just remove the CDN. So if you look at the QRL here, if you look at this one right here specifically, you notice that there is a hash in the middle, and hash doesn't get sent to the server, right? Hash is the client side. And we did this intentionally because we wanted to separate it out, the piece of information that the server needs and a piece of information the server does not need. And because the question mark is after the hash, it never gets to the server. If you put the question mark in front of the hash, then it would get sent to the server, right? So think of the question mark really think of this as a function call, and think of the question mark as a parameter, right? And depending on how you build up this URL, you get to control what things are actually sent to the server and what things do not. So in this particular case, adding a to-do is a client-side operation. The server doesn't need to know about the details of it. We're just saying, I just need this code, right? So there's no need to tell the server like which particular item I'm adding or anything of that sort, right? But in other cases, you might need to do that, and you could do that. So that's really up to you as how you use these URLs. As of right now, right. So this is another thing we're trying to figure out the details of. Oh, yes. The question was about propagation of events. Can you control them and play them back, etc. So events in JavaScript are fully synchronous in a sense that like once it fires, it propagates all the way up, and there's no way to do any kind of async operations. So what we actually do, or the way we're going to solve this, is not fully working yet, is that when an event happens, we cancel it immediately. So it doesn't propagate, right? The first listener that gets it, gets it. Because everything in the framework is fully asynchronous, because at any point, the framework can be like, oh, I need to download more code to continue, right? This is the thing that kind of the magic of the framework. So it's fully asynchronous all over the place, including event processing. Because of that, we have no choice but to cancel the event, and then we simulate the event continuously being propagated up, right? So once this lazy loaded event handler that's fully asynchronous completes, it can then say like, yeah, continue the propagation of the event. But at that point, we're just simulating it and going up the tree. And because of that, we have full control of what we can do with it. I think there's a question back. Right. So the way I think about it is the problem with existing frameworks is that they don't give you a hook to have proper asynchronous loading point, because existing frameworks are fully synchronous, right? The rendering is fully synchronous. The event processing is fully synchronous, right? So like they say like, of course you can do lazy loading, right? But they don't give you anything, and the stuff they give you is synchronous. And so it's like, it's really, really hard to do these things. Framework, this thing is fully asynchronous. However, it doesn't mean just because I give you all of these places where you could do a synchronous operation, it doesn't mean you have to, right? And so one of the things you could do is you could say like, hey, I've done some analytics and I've decided that actually I should just bundle the whole thing into a single JavaScript file, push it all at the beginning, and be done with it. And maybe that's actually the best strategy you can do. The point is, you could make that decision independently of the way your application works, right? Because these things, the debate of like, can I do something with, is it actually being done, are separated. You can do that, right? And so you can certainly decide like, oh, it's just a single HTML page, single JavaScript thing, big bundle. I'm just going to push it at the very, very beginning, and it's fine. And sure, you could do that. And nothing in your application changes, right? Whereas if you look at a classical application and you want to introduce a point of asynchronicity, oh my gosh, you're going to have to redesign a whole bunch of things and move things around. And, it's going to be a hard work that most people just won't do. So really, you should think of it as in like Qwik enables this fine-grained lazy loading. It doesn't mean you have to do it, right? One of the things we want to do is we want to keep statistics on about how people actually interact with the page and what is the most likely thing that you will do. And then based on that information, you can bundle it together and change your bundles accordingly. Did I say statistics? I meant to say AI because that's a fancier term. Sorry, was there another question somewhere? From the back. Should we just drink more beer? All right, if there's no more questions, I'm going to be here and ask me questions, mingle, etc. Thank you for being such a good audience, such a good set of questions. I appreciate it. This is my passion. This is what I love to do. So I always am excited when somebody's willing to listen to me.